A fighter jet flies fast, you know. People see its speed. People see its shapes. They see the pilot. They see the wings. But some things hide on a plane. Some things are secrets. These secrets can change how wars happen. Today we talk about one secret. It is inside the Gripen. The secret just turned on. The sky may not feel the same again. In the quiet data centers, in secure hangars, a command was sent, without a flash or a bang. A new capability, developed in the shadows for years, became active across the fleet. The airframe looks the same, the engine sounds the same, yet its ability to perceive and interact with the world was irrevocably altered. The Gripen is a small, smart jet. It is made in Sweden. Many countries use it. The plane is light. It is quick to fix. It can fly many missions. People know the Gripen for being clever and cheap. Now it has a new feature. The feature is top secret. It is not a normal weapon. It is a hidden system. It may change fights in the sky. This is not about a bigger missile or a faster engine. It is a software-defined upgrade, a latent potential built into its hardware that has now been unlocked. A philosophical shift in air combat, from brute force to intelligent, distributed awareness. The Gripen can now talk in a new way, use data fast, and hide while knowing a lot. The new system mixes sensors and computers. It makes the plane aware in a new way, like giving the pilot a new set of eyes. These eyes can see where others cannot. It is a passive system, designed to listen, designed to process, designed to understand the electronic environment with unprecedented fidelity, building a perfect picture without making a sound, turning the Gripen into a silent, all-seeing sentinel. Think of a night scene. A Gripen flies over a dark field. Radios are quiet. A radar lights up the sky, but the new system can listen in new ways. It can use tiny radio signals. It can see changes in the air. It can spot hidden things. It can find even quiet drones. It can map the sky without shouting. This is a big step. The jet can find threats and stay hidden. This capability, the Cognitive Electronic Warfare Suite, transforms ambient electronic noise into a high-fidelity map, allowing the jet to detect, classify, and track targets without ever emitting a powerful radar pulse of its own. The new system fundamentally changes the Gripen's role from a multi-role fighter to a true information-age combat asset. It moves beyond the traditional dogfight or bombing run. Its greatest weapon is no longer just the missile under its wing, but the data it can gather and the decisions it can enable. This upgrade makes the Gripen a node in a larger network, a brain that processes information for the entire force. A single Gripen can provide targeting data for friendly artillery, ships, and other aircraft operating with sensors turned off to remain hidden, making the entire force more lethal and resilient. This advantage is like the difference between a loudhailer and a sensitive microphone. Older jets had to shout with powerful radar emissions, revealing their position, like yelling in a dark forest. The Gripen can operate like someone with exceptional hearing, pinpointing by the rustle of leaves or the snap of a twig. The cleverness lies in adaptability. It is not a static library of known threats. It uses machine learning to analyze unfamiliar signals in real time. If an adversary deploys a new radar or drone, the system learns its signature on the fly, then shares it across the network, so every unit is instantly updated. Its advantage grows with every mission, constantly adapting to changing tactics and technologies. It is a system designed for the long game. The system works in 3 parts. The first part is sensors. The sensors are many. They are small. They listen to different signals. They read radio waves, heat, and light, even tiny changes in reflections from TV and cell towers. This distributed multi-spectrum array is called a passive coherent location system, a spider's web across the spectrum that is hard to jam. The second part is a brain, a fast computer that takes many signals at once, finds patterns, guesses what is real, learns from mistakes. With AI, it fuses inputs into a single picture, filters noise, correlates faint signals, pinpoints targets, and assesses threat, from civilian airliner to small drone swarm, with high confidence. It can feed false data, create ghost targets, and hide the true location of friendly forces, turning reliance on electronics into a vulnerability. Think of a team. The sensors bring news, the brain decides, the actions follow. The pilot still leads, but the system makes choices very fast and presents clear options. For example, it might display a suspected air defense unit with a 95% confidence label and suggest 3 flight paths to avoid it. One key idea is stealth and visibility. Now the Gripen keeps quiet, using small, smart bursts and complex waveforms that hide in background noise. This mode is made for networks. The Gripen links to drones, satellites, and ground stations. The link is fast and safe. The plane shares targets, passes control, and requests data. A passive Gripen can detect a target and transmit to a ship hundreds of kilometers away, which launches a missile. The Gripen acts as the eyes, another platform as the fist. Fewer shots, more effect. It does not need bigger bombs. It helps aim better. It helps time attacks. It chooses the right weapon and enables small, precise strikes. With a perfect, real-time picture, weapons are used with maximum efficiency. It predicts movements and recommends the moment to fire, increasing the chance of a single weapon hit. The true power unlocks when multiple Gripens work together, spread out, all listening. By combining data from separate vantage points, they triangulate enemy transmitters with extreme precision. This is multi-static reception, making passive detection exponentially more powerful. One listening post gives a direction. Several give an exact fix, creating a decentralized sensor grid. If one jet is lost, the picture holds. Older forces relied on a single AWACS. Lose it, go blind. Now every fighter is a sensor, feeding the whole, and connectivity extends to sea and land. A Gripen might detect a cruise missile swarm and instantly send tracks to a destroyer whose crew engages without delay, compressing the sensor-to-shooter timeline. Ultimately, this builds a combat cloud, a shared battlefield consciousness. A pilot is no longer just flying a plane. They are a key node in a vast, intelligent system that lets a smaller force act like a single, smarter organism. Imagine a patrol near a coast. The radar shows nothing. The pilot sees only blue water and clear skies. But the cognitive system is listening. It detects faint signals unlike civilian patterns. The AI analyzes frequency, duration, and modulation, cross-referencing its threat library. It flags a pop-up coastal missile battery. Small blips from a drone swarm appear, too small and low for traditional ground radar. The Gripen links to a satellite and finds a pattern in the radio noise, confirming the drones are tied to the battery. The system fuses the data. A coordinated attack is imminent. A quick encrypted burst sends exact battery coordinates and drone flight paths to a friendly task force over the horizon. The commander launches a long-range missile. Simultaneously, the Gripen uses a focused, low-power beam to break the swarm's command link. The swarm loses coordination and scatters. The naval missile, guided by the Gripen's data, strikes the battery. The mission ends with no big explosions near the Gripen, decisive effects from a safe distance. But there are trade-offs. New tech brings new risks. The system needs software. Software can have bugs. A bug may hide a real threat or create a ghost in the machine. If the AI misreads signals, it could lead to a catastrophic error. The jet must be safe. The computer must not override the human. Rigorous testing, continuous testing, and validation are essential to ensure reliability under combat pressure. Another risk is being hackable. Every link is a door. A skilled enemy may feed wrong data poisoning, teaching the AI bad lessons or prompting strikes on false targets. Good cybersecurity helps, but none is perfect. Nations must plan for attacks and develop procedures for compromised or degraded networks. Resilience is as important as capability. Hidden passive systems can push an arms race in the shadows. Ambiguity makes crises unstable. Leaders must set rules of engagement and keep humans in control, while training to fight if the tech fails. Let us look at the pilot. They sit in a small cabin with a mask and a helmet. Their screen shows maps and blips. Now the screen shows smart hints, confidence levels, potential identities, suggested courses of action. The pilot still chooses. The system offers better choices. Cognitive load is reduced, giving time to think strategically. Activation feels like turning on a new instrument. Crews test in controlled environments, run thousands of simulations, train for faults, and learn to spot signs of compromise. Allies may want the same tool, new interoperability and demand, but laws and ethics matter. Nations must set rules and ensure a human operator is always in the loop for lethal force. The Gripen's hidden upgrade is a transformation. Passive sensing, cognitive computing, and networked data sharing yield powerful situational awareness. It sees with clarity while remaining electronically silent, allowing smaller forces to fight smarter. Information equals firepower. This is a start. The tech will spread. Counter-tactics and electronic camouflage will evolve. Rules must be refined. Keep the human in control. So, a silent switch has been flipped. The strategic landscape has changed. Watch the skies in a new way. Sometimes, the sharpest edge is quiet code and quick thinking.